Hi, my name is Aditya and I am the CEO of Automatsky. Automatsky makes the most powerful quantum simulators, annealers and computers in the world. Today I am going to show you how to solve Boolean satisfiability problems using Grover's algorithm, which uses oracles. And I will keep it extremely short. I assume Automatsky has already given you the context of this video, so you will understand what I am going to show you. If you receive this video by mistake and don't know what this is all about, just ignore it. I am here to tell you about the breakthroughs we have achieved and not how we have achieved it. All our millennium breakthroughs are completely our own inventions without absolutely any collaboration or help from anyone else. All the implementation details of our inventions will remain a proprietary secret for the next 1000 years. If that doesn't work for you, then you can stop watching this video. Now, Automatsky systems are developed, made, are built to order, and they are hosted in our data centers. And today we are going to use Automatsky's billion qubit quantum computers, which have been in existence since 1997. They are hosted in our data centers and are made available to customers over a remote API. But today we are using a small test bed instead of the production infrastructure. Now, in 1997, Bennett, Vazirani and al. Proved that quantum computers cannot solve NP-hard problems in sub-exponential time. And since the Grover algorithm was optimal, the minimum time solving NP-hard problems will take is 2 to the power n by 2, where n is the number of variables. Now, Boolean satisfiability problem is a classic combinatorial problem in which you are given a Boolean formula of n Boolean variables. The problem is to find the values of the variables on which the formula takes on the value true. Now it is represented as multiple clauses put together. So here you can see in the center there are 3 clauses. Each clause is in a bracket, and there is an and between all the clauses because all clauses have to be satisfied. But within a clause you have multiple variables whose values should be true, so that the clause is satisfied. So let's see what this problem means. Now, here in the first clause, variable number 1 can be true or variable number 2 can be true. If either of those is true, then the clause is satisfied. In clause number 2, variable 2 can be false, variable 3 can be true, or variable 4 can be false. If either of those conditions are satisfied, clause number 2 is satisfied. And in clause number 3, variable number 1 can be false or variable number 4 can be true. If either of those conditions is satisfied, then clause number 3 is satisfied. And if you have some values of all these variables which satisfy all the clauses, then you have solved this specific Boolean satisfiability problem. If you look at this carefully, variable number 1 true, variable number 2 false, 3 false and 4 is true will make this problem satisfied. Just in case a formula is not satisfiable, it is called unsatisfiable. This means that it takes a value false given any combination of values of the variables. This is a sample file format in which the problem is stored. This is called a Dmax format, and in which CNF SAT problems are stored. Here, this line says that there are 4 variables and 3 clauses. Remember, these 3 were our clauses. Look at the first clause. Variable number 1 or variable number 2 can be true. So we write it here like this. 1 can be true or 2 can be true, followed by 0, which is the end of the statement. Okay. Look at the second clause. 2 can be false, 3 can be true, or 4 can be false. 2 can be false, so it is shown as negative. 3 can be true, or 4 can be false, so it is shown as negative 4. And then followed by a 0, which ends the statement. Similarly, the third clause, 1 can be false or 4 can be true. This is how a problem is represented and it is given to solvers to be solved. Usually what you do is you try all combinations starting from one variable, assigning it 1, 0, and then assigning all the other variables 0 and 1 by one in a tree format till you find a combination that satisfies the problem. Now the problem is that Boolean satisfiability is a fundamental problem in computer sciences and complexity theory. It is NP complete and it is the first problem that was proven to be NP complete. And one of the reasons that people are trying to build quantum computers is to do quantum simulations and to solve NP hard problems. Now there is no known algorithm that efficiently solves Boolean satisfiability problem in polynomial time. There are a lot of heuristics which solve tens of thousands of variable problems and formulas with millions of symbols, etc., which is enough for the problems scientists encounter in AI, circuit design, theorem proving, etc. But there is no solution that can solve this in polynomial time. And like I said, Bennett, Vazirani et al. Also have proved that quantum computers also cannot solve NP hard problems in sub-exponential time. They will take 2 to the power n by 2 time to solve the problem, where n is the number of variables. How do you solve a Boolean satisfiability problem on a quantum computer? Basically, you make a circuit and prepare the state here, and then you have an oracle which contains all the Boolean formulas, and then you have something called a diffusion structure, and you run this oracle 2 to the power n by 2 times, and it is clear that this is clearly exponential in computational complexity. But this is the way NP hard problems are solved on quantum computers, and this is exactly what we are going to show you today. Now time for a quick demo. Here I have a lot of problems and I am going to explain what we are doing. So here we are calculating first the number of times to run the oracle. So we'll create a quantum circuit and run the oracle 2 to the power n by 2, where n is the number of variables. Okay. And we'll start the timer, we'll load the variables and clauses, we'll create a circuit. Here we are creating a circuit. We are executing a certain gate on the qubits, and here is the oracle, and if you see this loop, it is running the oracle the given number of times, which is exponential. And then basically in the end we do measurements, and if we find a combination through measurement which satisfies the problem, we print it out and we stop. Okay, and we print the status of progress of execution of gates in between. So that's what we are doing here. Now here is a problem with 5 variables and 10 clauses. Now this will have, the quantum circuit will have around 50 qubits and around 400 gates. Okay. Let's see. So here, 97 gates. Okay. So you see this solution here, 1 1 1 1 1 solves the problem. Okay. Now this is a problem with 10 variables and 20 clauses, and this will use around 200 qubits and let's see how many, I think 1400 gates. You see here, it has executed 1409 gates and it has printed out the solution. The variable number 1 is 0, variable 2 is 0, 3 is true, 0 means false, 3 is true, 4 is true, 5 is false, 6 is true, 7 is true, 8 is false, 9 is true and 10 is false. This satisfies the problem. Okay. This is, I think, beyond what anybody has solved till now. But let's solve a 20 variable problem, and I'll tell you how many gates. It will use around 500 qubits and around 1,90,000 gates. So this is executing on Automatsky's billion qubit quantum computers, and we will be executing 1,90,000 gates. Okay, so let's run this. You see this? These gates are being executed, and this is a 500 qubit circuit, 500 logical qubit circuit. Nobody in the world can do this as of today. See here, it has solved the problem in 15 seconds. Thank you. Now, it is a pleasure for us to explain our inventions, and we will not be disclosing our implementations and designs of our quantum computers, but it is available for purchase. We sell quantum annealers, quantum simulators, quantum computers, and in the future we will be selling our quantum gravity computers, besides quantum simulation systems and various other systems. So please reach out to info@automatsky.com if you have any questions. Thank you very much.